What are the limitations of GPR? Have you ever wondered how archaeologists peek beneath the surface without digging? Ground-penetrating radar is one of the tools they use, but it does have its limitations. Let's break down what those are. First, the effectiveness of ground-penetrating radar is influenced by the type of soil and environmental conditions. For instance, if the soil is rich in clay or saline, the radar waves struggle to penetrate deeply. In wet conditions, the radar might only reach about 1 meter. On the flip side, dry sandy soils can allow penetration of up to 17 meters. However, if there is surface moisture, it can hinder the quality of the data collected. Conductive environments, like seawater or salty soils, are not suitable for ground-penetrating radar either. Additionally, rough terrain or surfaces cluttered with metal debris can complicate data collection. Next, let's talk about penetration depth. While ground-penetrating radar can reach various depths, it is generally limited compared to other geophysical methods. The maximum depth often ranges from 1 meter to several meters, depending on soil type and moisture. This limitation can restrict the detection of deeper archaeological features or structures. Another challenge is the complexity of data interpretation. Ground-penetrating radar produces radar images that show anomalies, which are areas where the subsurface differs from the surrounding material. However, these images do not tell us exactly what the anomalies are. Interpreting this data requires specialized knowledge and experience. Misinterpretation can lead to incorrect conclusions about the presence or type of archaeological features. Often, ground-penetrating radar results need to be confirmed through excavation. Cost is another factor to consider. Ground-penetrating radar equipment can be quite expensive. This can be a barrier for smaller archaeological projects or organizations with limited budgets. The costs include not just the hardware but also the need for trained personnel to operate the equipment and interpret the data. Logistics also play a role in ground-penetrating radar surveys. The effectiveness of these surveys depends on practical factors like the size of the area being surveyed, accessibility, and weather conditions. For example, surveying large or difficult terrains requires more time and resources. Adverse weather can delay or degrade the quality of the data collected. Understanding prior site disturbances is also important for managing expectations about what ground-penetrating radar can detect. Finally, ground-penetrating radar detects contrasts in subsurface materials but cannot specify what those contrasts are. An anomaly might indicate a wall, a pit, or even natural soil variations. This means that ground-penetrating radar cannot provide definitive archaeological interpretations without additional methods or excavation. In summary, while ground-penetrating radar is a useful tool in archaeological excavation, it has limitations. These include sensitivity to soil and environmental conditions, limited penetration depth, the need for expert data interpretation, high costs, and logistical challenges. Archaeologists often use ground-penetrating radar alongside other methods and follow up with targeted excavation to confirm their findings.